Hello everyone, I am RoboTou. RoboTou Stacker has recently been updated to version 4.0.0. Compared with the previous version, RoboTou Stacker will be a little different. This is a user guide. First open the software. Let's first look at the Starry Sky time-lapse stacking. This is a typical file structure for a Starry Sky time-lapse stacking. We have many different ways to set the input image folder. We can click the button to select the folder you want. You can also drag the folder to this button to set the input. At the same time, we can also select the pictures you want. To stack the image, then you drag it to this button. This also sets the input. Unlike before, in our previous Windows version, file names and file paths could not contain Chinese characters. That issue has now been fixed. Let's look at the output. There are two ways to set output. The first one is create automatically. For example, if the input is set to a folder, the software will automatically create an output folder in the same parent directory, named by appending the suffix output to the input folder name. If the input is set to multiple images, the software will create a folder named output in the same parent directory as the images, and use it as the output folder. If there is a naming conflict with these folders, the software will append a numeric suffix to the folder name. At the same time, we can also select manually our output folder. One important point is that this auto-creation happens only when you click Start button. The folder is created at that moment. Here we select a mask. There is an automatic filling of mask gaps. It is for some of our masks. There are some white holes in the black landscape. We will recommend that you automatically fill the mask gaps, but there is no holes in our mask, so we do not need to check. Here we also have an auto-skip unaligned frames, mainly for the time-lapse of some day to night and night to day. During the day, there are no stars, or after the clouds in our sky block the stars. In this way, it will appear misaligned. After you check this, it will align everything that can be aligned for you at once. It will generate a missing_frames text file to tell you which frames are missing. You can use other stacks to fill in these frames. For example, you can use landscape time-lapse stacking to fill in those frames. You use the same stack type and the same stack size. There is a stack type. There is a mean value, a median value, a maximum and a minimum value. We generally use the mean and the median value. The mean value, the noise reduction effect is the best. It is also fast. The median value, its noise reduction effect is slightly worse than the mean, but its deflicker effect is particularly good. It is also slightly slower than the mean. Just set the stack size yourself. Generally speaking, once the stack count exceeds 15, denoising no longer provides noticeable gains, but deflicker still does. After we set it up, click Start and it will start running. We see that it has finished running. Let's take a look at the results. It runs out two results. There is a Starry Sky fisheye time-lapse stacking. The settings are the same. I won't say much about it. There is also a Starry Sky reflection time-lapse stacking. It is different from the Starry Sky time-lapse stacking. It has two masks. One is the sky and earth mask. The sky of this mask is white. The others are black. There is also a reflection mask. The reflection of this mask is white. The others are black. Drag these two masks to the button. Everything else is the same. Just click to start. We also have a meteor shower video stacking. It takes a directly recorded meteor shower video and stacks it into a video where meteors look like falling rain. IT requires the camera to remain fixed while directly recording the meteor shower. We have two input methods. One is the long video that you record directly. For example, this video. It has been recorded for about 5 hours. This kind of long video can be input directly. In addition, if you've split the meteor shower video into many short single meteor clips, you can drag the entire folder onto the input button. Or just drag a few selected meteor clips onto it. The output settings are the same as we explained earlier. Automatic creation, manual selection, and so on. So we won't go into detail here. Meteor shower stacking also requires a mask, and you can drag the mask directly onto the mask button. Here, Auto Calibration Distortion. When you check this option, it will prompt you to choose WCS file. How can we obtain this WCS file? First we open Photoshop. Open our video. You select a frame like this. The stars are not blocked by clouds. We just select the first frame here. File. Export. Save for web, legacy. Just click this to save. This is the frame we saved. Let's take this frame. Open this website of nova.astrometry.net. Click this Calibrate and Share. And select a frame here. Select this frame. Open this advanced setting. We mainly focus on this position. Position here. Check this. Upload. It will start to solve its lens distortion parameters. There is a success here to represent that it has run successfully. Let's click Go to Results page. We will get this page. What I just want is this file of wcs.fits. Let's right-click on it. Just save it. After saving, we have a WCS file. Drag it onto the WCS button. And we can start running. It is worth noting that most of our lenses do not have this lens distortion. They can be aligned and stacked very well. Only in some fisheye lenses. Or in some video surveillance cameras. They will have some distortion need to be calibrated. However, this website cannot solve the distortion parameters successfully every time. And it may fail. So if you want to use this module, I recommend recording meteor shower videos with a lens that has little or no distortion. Most camera lenses, as long as they are not fisheye lenses, have minimal distortion and can be aligned and stacked well. When the input is set to raw video, you need to choose a clip generating mode. One is by fixed length, and the other is by meteor event. If we choose by meteor event, 3 additional parameters will appear below. The first one, split interval, minutes, defines how many minutes each input video chunk should be. The default is 60 minutes. It is recommended not to set it too long, because after alignment and stacking, meteors may move out of the frame. Detect interval defaults to 8. It means the current frame is subtracted from the frame 8 frames earlier. To detect meteors using frame differencing, a smaller value makes it easier to distinguish meteors from airplane trails. But it may also filter out some meteors. A larger value keeps more meteors, but airplane and satellite trails are more likely to be misidentified as meteors. Min hit frames defaults to 8. It means a meteor is only confirmed if it is detected in 8 consecutive frames. A larger value makes it easier to distinguish meteors from airplane and satellite trails, but it will also filter out some real meteors. A smaller value preserves more meteors. But airplane and satellite trails are also more likely to be mistaken for meteors. If clip generating mode is set to by fixed length, the software splits the input video into 30-minute segments, then divides each segment into 10-second clips for alignment and stacking. The starless module can separate stars from the background. The input-output setup is the same as before, so we won't repeat it here. Tile overlap size works like this. We split a full image into many 256 by 256 tiles. Remove stars on each tile, and then stitch them back together to complete starless for the whole image. This requires overlap between neighboring tiles. The default is 32. Larger values usually give better results but run slower. Smaller values are faster but may reduce quality. After all settings are configured, click Start. Here, the output folder is output_01. And it generates two folders, one for starless images and one for star mask images. Let's look at the results. For example, this photo contains stars. This is the original image. This is the starless image. This is the star mask image. Landscape time-lapse stacking. The operation is the same as before, so we won't repeat it here. There is also the toolbox, mainly used for raw decoding. It was already covered in previous tutorials, so we won't go into detail here either. There is one more thing to mention here, the task queue. For example, after configuring the parameters in the modules above, you can right-click and select Add to Task Queue. That task will be added to the queue. Add several tasks, click Start. And the software will run them one by one in order. Alright, that's our tutorial. Thank you, everyone.